So this lesson is going to be a little bit difficult. Next lesson is also difficult, but do not worry too much. Week 27, 28 lessons are a bit difficult. It's because we are trying to expose you to those questions that are more difficult, that could be tested in your schools. We saw it before, we've seen it that has been tested, but it is not common. Because it's been tested, we need to expose you to those questions. All right. Let's look at question 1. If Amber gives $20 to Yenny, Yenny will have twice the amount of money Amber has. If Yenny gives Amber $2, Amber and Yenny will have an equal amount of money. How much money does Yenny have? So there's two if, right? If and if. So it is two scenarios, right? Two scenarios that actually didn't happen. So the first scenario is that if Amber gives $20 to Yenny, so Amber will minus 20, Yenny plus 20. This is how you describe your scenario, okay? This is how I record it to describe it. Yenny will have twice the amount of money Amber has. So you do this ratio. Yenny twice Amber 1. Now, the second scenario is Yenny gives Amber $2, so Yenny minus 2, Amber plus 2, and the ratio will be Amber and Yenny will have equal amount, so 1:1. Back to the basics, whenever there's two ratios, you must always look for common base. And the common base is the total in both scenarios is the same. Okay, because they are in both scenarios, you are just giving the sweets to each other. Not sweets, not total sweets, total amount. Got to change this. So total amount of money is the same. 1 to 3, this change to 1 plus 3 is 4, 1 plus 1 is 2. Okay, and let's make 4 and 2 the same. Multiply. So now multiply 2 on this ratio, you get 2 to 4. So the common base is done. Step 1, record data. Step 2, look for common base. Step 3, look for value, right? Now, the value, you can either use the value of Amber or the values of Yenny. Now, if I want to, in this solution, we use the value of Amber. So we compare Amber, 1 unit of Amber here versus 2 units of Amber here. 1 unit versus 2 units, meaning in both scenarios, there's a difference of 1 unit. Right, and the difference is because in this scenario, Amber has $20 less. In this scenario, Amber has $2 more. So the difference between Amber in both scenarios is actually $22. Claire, Andrea, correct. Do you know why? Why is $22? Because you look over here, Amber, scenario 1, Amber has $20 less. In scenario 2, Amber has $2 more. The difference between Amber in the first scenario and the second scenario is not 20 minus 8, it's 20 plus 2, 22. Okay? So one is $20 fewer, one is $2 more. The difference is 22. Got it? Who got question? This is a common mistake. People do 20 minus 2. That's what a lot of people will do. So now I tell you, don't make these mistakes again. Okay? So $22 is equal to, from 1 unit to 2 units, so $22 is 1 unit. Now, answer the question. How much money does Yenny have? So how much money does Yenny have at first? Or rather, there's no at first. In both scenarios, Yenny's money is the same. So if I were to pick scenario 1, I'll be using this Yenny 3 units. But do remember that in this scenario, there is a hypothetical $20 given by Amber to Yenny, which didn't happen. So we need to take that out. So 3 units is equal to 3 times 22, 66. I need to remove $20 because in this scenario, we presume that Amber gave Yenny $20, which didn't happen because the if. So answer is 46. However, if you were to use scenario, if we were to use scenario 2 to find Yeni, which is this 2 units, then you'll be 2 times 22, 44. Okay, but do take note, in this scenario, Yeni gave $2 away to Amber, but she actually didn't. Okay, so you got add back the $2, and that's how you get 46. Answer is the same for both scenarios. Okay. Now, question number 2, everybody. So there are some bits, Braden, you're correct. There are some bits in box A and box B. If 12 bits are taken out from box A and transferred to box B, both boxes will have the same number of bits. If 15 bits are transferred from box B to box A, the number of bits in box A will be twice the number of bits in box B. Chunk of words, right? So break it down. So the break it down to 2 scenarios. The first scenario is if 12 bits are taken from A to B. Okay, 12 bits taken out from A and give it to B. That's how I record. The ratio become 1:1, same number of bits. Okay. Now, do it step by step. So second statement, if 15 bits are transferred from B to A, meaning you take out 15 from B and give it to A. The ratio will be A will be twice B. So A is 2, B is 1. Just like before, total don't change because in both scenarios, the bits are being given to each other. All right. Okay, now, so this is 2 and this is 3. So let's make 2 and 3 the same. So the common base is done. Now look for a value. The value, you can use either A or B to find the value, right? So if we were to use A, then we compare 3 units and 4 units. So A has increased by 1 unit. Or rather the difference, not say the increase, rather the difference between A in scenario, in this scenario and A in this second scenario is a difference of 1 unit. In terms of value or bits, in first scenario, A is 12 fewer. Ignore Amber, it's supposed to be A. And in scenario 2, A is 15 more. So in terms of a time or number line, it looks like that. First scenario, 12 less. Second scenario, 12 or 15 more. So the difference between these 2 scenarios is 12 plus 15. 12 plus 15. This actually is here. So from here to here is 27. Okay. So the difference between the 2 scenarios is 27, which is in terms of units, the difference is 3 and 4 minus 3, 1 unit. So 1 unit is 27. Now we can read the question. The question is asking how many bits are in box A at first. So we're looking at this. You can either use this or this. First scenario, A is 3 units and I'm add back 12. Okay, because minus 12. Add back 12. 3 units, add 12. 93. If I were to use the second scenario, A is 4 units. And look here. In this second scenario, there's a if A received 15, but A actually didn't receive 15. So I need to minus away 15. Answer is also 93. All right.